Hello 8th grade, my name is Mr. Rogers and you're watching the video lecture for 3-2. This is on transmitting fluid pressure, or really most of the time we're going to be talking about Pascal's principle. So our lesson objectives for the day are: 1, to explain Pascal's principle, what it is, what does it mean, and number 2, be able to explain how a hydraulic device can multiply the force on an object. So really these two big ideas, and one, hydraulic devices is tied into Pascal's principle. So before we begin, I know we have a friend who's been helping us out. And Arnold Schwarzenegger, he's here. He doesn't want to come on camera. He's kind of shy. But last time you said you would help out more in this video lecture. How do you feel about that right now?
I lied.
You lied, so you're not going to help out? Gee, thanks a lot. Well, we'll come back. Maybe you'll help us out later on. So, getting started here, guys. The idea of Pascal's principle. Pascal's principle says, simply, when a force is applied to a confined fluid, an increase in pressure is transmitted equally to all parts of the fluid. Okay, what does that mean? It's actually a really simple demonstration I'm going to do. There's going to be a screen in a second that'll kind of explain the pressure on a water bottle and how that changes. So when you get that, you'll be able to see the video and watch what happens there. And secondly, when that video is done, you'll watch a video on a hydraulic system or a hydraulic device. And hydraulics are everywhere. Think about how we get a car up on a car lift in a mechanic shop. They're really found in a lot of different places. But a hydraulic system multiplies a force by applying the force to a small surface area. The increase in pressure is then transmitted to another part of the confined fluid, which pushes on a larger surface area. And that force is then multiplied to create a greater force on one side than the other. So it's all about using that Pascal's principle, that confined fluid. Now we can use that to increase force. So following my little video lecture here, there's going to be two different videos to watch. Before we continue though, Arnold, do you have any questions you want to ask? Anything you want to think about there?
Who is your daddy and what does he do?
I am not going to answer that question. So since you have nothing appropriate to add to this conversation, we're moving on. So from here, guys, you're going to see those two videos, one on Pascal's principle and a water bottle, and the second on how hydraulic devices work. So I thank you guys for watching, and we'll see you guys along the way. All right, so Pascal's principle says that when you increase the pressure on a confined fluid, such as our water bottle right here, that the pressure is distributed evenly to all parts of the confined fluid. So if I were to squeeze, if I was to squeeze on the water bottle on the sides, what that means is inside here the pressure is changing everywhere, not just where I squeeze, not just here and here, but everywhere. That pressure is transmitted equally to all parts of the fluid. So no matter, just because I squeeze in one place, it doesn't matter. That pressure that's added is increased all over the confined fluid. So when we talk about Pascal's principle, we were talking about the idea that when you increase that pressure in a confined fluid, the fluid transmits everywhere inside that fluid. So not just a water bottle. Think about enclosed pipes or tubes that have liquid or air in there. Think about pneumatic pressure. Kind of goes back to the idea of when you change the pressure inside of that confined fluid, that pressure goes everywhere. All right, guys, we are talking about hydraulic devices, and a hydraulic device uses Pascal's principle, which says that if we increase the pressure on a confined fluid, that pressure is transmitted equally to all parts of that confined fluid. So when we think about this, I have a picture here of a very simple piston. And let's say the one on the left and the one on the right. The one on the right would be where, let's say we have a car up here. We have a big arrow. But let's give ourselves... So now we have a car on the right-hand side of our hydraulic lift. And think about in a mechanic shop, when they want to put that car up on the hydraulic lift. They're going to use this idea of Pascal's principle to create this hydraulic device. So what they're going to do is use that idea of how we multiply the force. This is all about multiplying the force. So on the left-hand side, let's say we have the piston area here under piston area A1. Let's say that particular area is 5 centimeters squared. So our area is 5 centimeters squared. And we'll say that area 2 over here is 25 centimeters squared. So now we've increased that area by 5-fold. So the right side is 5 times bigger than the left-hand side. So that's kind of one of the key things to keep in mind. The other one is how much force is applied. So our force here is F1. And let's say we'll apply with a force of pretty small, just 2 newtons. There's 2 newtons of force pushing down on this piston. So the question is then, how much force will be pushing up on our right-hand side? And so to do this, we have to do a little bit of math. And we're going to jump ahead a screen here. And we need to know a couple things. So our force was 2 newtons pushing down. And you're going to be multiplying that by some number. So if I go back here, we have 2 newtons of force pushing down, and my area is 5. So my area is the 5 centimeters squared on the right-hand side. On the left-hand side, it was 25. So it's 25 centimeters squared. So the big idea to know, how many times bigger is the right side than the left side? So 25 divided by 5 would give me 5 times bigger. So that number 5 is what I multiply my newtons by. So 2 times 5 is going to give me 10 newtons of force. So back here, that means on this car right now there are 10 newtons of force pushing up on the car. And so the big key word here when we do this activity is about multiplying force. Figure out the area, how much bigger the area is, and you multiply the force by how much bigger the area is. Alright guys, I'll stop there. Thank you for watching.